Assalamualaikum. This is our presentation or demo video. Our group consists of 3 members, which is Muhammad AZIZI, myself, NURUL NAJIHA and IEZATTY NAJWA. Now we will look into the simulation of the program. So first we load the hex file and then we start the simulation. The pin at port D and port A is on because the switch is active low and the pull-out resistor is enabled. So first we will look into SD0 task. SD0 task will execute the running light pattern with 250 millisecond delay. The pattern will only run once for each time the switch is pressed. After this pattern, we will look into SD1. When the pattern is ready, when the loop is done. Okay, next we will look into SD1. SD1 will blink 5 times because of the loop with the same delay. And then for SD2 and SD3 uses interrupt, so we can demo the interrupt when the LED is still blinking. So when we press here, so it will display the addition. This is for SD3 task, so the addition will be 0 because the input at our pin A is 0. So this, the subtraction will also be 0 because 0 minus 0 is 0. So here 0. The multiply MUL will also become 0 because our first number and second number uses port A and both numbers are 0. The division will also be 0. If we change the lower number to 0, so this is 1. Oh, sorry. The upper number to become 1 and the bottom number to become 0. So the addition should be 1. ADD equals to 1. Oh, sorry, it's 1111 F, hex F, and the subtraction should be F also because F minus 0 is F, and the multiplication should be 0 equals 0, but the division will become E. This is because we cannot divide numbers with 0, it will get infinity. So then we will look into SD2 task that uses interrupt 0. This task will display the IC of our group leader, which is NURUL NAJIHA, and the delay is 350 milliseconds. This is left purposely blank for the gap between 2 zeros. Then we will wait until they finish displaying our leader's IC. We can test the addition and multiplication process using all F value for where the first number is F and the second number is also F. So we see the addition will become dash equals to dash. This is because the limit of our answer is only f, so any number higher than f will be dash, so the subtraction will equal to 0. Okay. The multiplication MUL will also be equal to dash because the multiplication number will be very big, and the division will become 1. div equals to 1. Okay, so the interrupt uses falling edge detection. For our assembly hex program, the result will be similar to the C program hex. For our assembly program, the result will be similar to this C program hex file simulation. The only difference is that instead of displaying dash, our assembly code will display the upper nibble first and then the lower nibble, so it will display two numbers for each addition and subtraction. That is all from our group. Thank you very much for listening.